Mustafa.
Thanks. Thank you, everyone. I am Mustafa. I'm the PI of the project. This project was done in collaboration with colleagues from computer science, myself, Yanis, Jochen, Eduardo, and Lucas, and colleagues from the Department of Criminology, Meropi and Laura. So the main work was done by Yanis, the technical side, and Laura on the social aspect, the social science. Unfortunately, Laura cannot be here today, but Meropi will cover. So there will be 3 speakers, myself introducing the project, and then Yanis covering the technical side, and Meropi the social aspect. So the key component of our project is formal software verification tools, or automated software verification tools. But why exactly those? So apparently, if you look at some reports from 2022, US companies alone, they spent nearly like $2.5 trillion just because of pure software development. And this could come from different reasons: legacy software, unsuccessful projects, cybersecurity, etc. But what I found most interesting is that if you look at the cost of developing software code, more than 50% of that cost goes to fixing, finding, understanding, and fixing bugs. So less than 50% actually goes into developing the code, but more about fixing the code. And that's why we focus on software verification tools. And our department is quite good in developing tools which we can use to find bugs in software. Very apologies, I should have included also some tools developed by your group.
It's okay, I'll forgive you.
So different research groups use different methodologies to devise these codes. So our group, S3, we predominantly design tools for analyzing source code. And these tools are quite good. So we participate in competitions, we regularly win prizes in finding bugs. We also collaborate with some big players, Amazon, ARM, Intel, Microsoft, etc. They try to deploy our tools and to find bugs in their software. As I said, we are good but not perfect. So we still have some time and some room for improvements. So these were our research questions. Number 1, can we actually use large language models, combine them with formal verification tools such that we are better in finding bugs, explaining bugs, or even fixing bugs? And from the social aspects, according to us, everyone should be using these tools because they're good. And they're open source, everyone could use them. But only few big players are using them. Like why we don't see higher deployment by industry? Is it because people don't trust them? Is it because they are not scalable? Or is it because they are difficult to use? So these were the answers these were the questions we were asking ourselves. So I'm gonna hand over now to Yanis, who will zoom in into some technical aspects of the project. And then I will he will hand over to Meropi for the social part.
Thank you. Hello, my name is Yanis Haralambos, and so we ran Turing experiments for this, and they were all focused around the repair of AI seed code. So the overall objective was to combine large language models and formal verification to generate efficient, robust, and secure AI code. And here we have the basic premise. So we start off with the source code and the verifier output, which is given by one of the tools that Mustafa outlined, which is the SBMC. And we create a prompt. We give the prompt to the LLM to generate a fix, and the LLM is the large language model. And we get the patched code back. If the verifier then is able to check if it has been successfully repaired, and then you get a verification outcome and you end up with the patched source code. So it could be either successfully repaired or failed. And so the first experiment we ran, we had to evaluate the ability of ESBM Seed to basically like repair, to basically verify this AIC code. So we started off with Neural Code Bench, which is a small data set of benchmarks made for these verification tools. They contain AI safety properties, but we removed them. We removed all those properties, and then we used mutation testing to expand it from 505 samples to around 80,000. And this graph shows the outcome of all these samples by ESBMC when it got verified, when it verified them. And there were 4 categories, and we managed to get quite a lot of safe samples, but a big chunk of them was unknown and unsafe. And this is an ongoing challenge to improve these tools to be able to basically like get better at reducing the unknown verification result. And this data set also, we can use it in future research where we want to train an AI model to repair code, to be special at doing that. We can basically use the unsafe code as the extreme to show the LLM problematic examples. And then we can use the safe code that we repaired using our experiments, which will be shown, to show the LLM what the fixed code should look like. So the second experiment was using prompt engineering techniques to find the best prompt for use for APR of AIC code. So what is APR? APR stands for Automated Program Repair. You have the verifier, you generate a mutation with the broken code using the feedback from the verifier, and then the LLM generates the fix, and then that is basically the premise of APR. So and it's basically what I showed previously in the graph. So in the diagram. So we found out from our best prompt, which can be shown in the gray box, 18% of successful repair for AIC code. We used different ways of showing the source code in the prompt. One of them was a single line, so we just showed the broken line. The other one was showing multiple lines. And we found out that showing only the broken line, in this case, resulted in a higher successful repair rate. And we also tried different personas, which are styles of prompting the LLM. You have chain of thought, you have persona, you've got other ones. We found out from the ones we did try at the time that persona worked the best. And the best role for the persona was automated code repair tool. We tried some other ones, and I think now if you read like the literature, it shows that automated code repair tool is used quite often, but back then that wasn't the case, I believe. So, and yes, showing, and also we also found out that showing the source code after the verifier output is better, and also we found one limitation in the existing large language models, in ChatGPT, was that it actually doesn't parse raw verifier feedback. So in this case, ESBMC's counterexample very well, as providing the raw feedback made the performance worse. Finally, our final experiment was to build an automated framework that uses iterative repair to fix the AIC code. So what is iterative repair? Once the sample once the verifier proves to you that the sample that was patched is still false, is still wrong, you basically add it to the existing prompt, and you kind of build a history of repairs, and that is the iterative aspect of that. And you do that up to a maximum of n times. In this case, we tried 5 times as a maximum. We found out that we increased our successful repairs to 25% for AIC code. And so iterative APR is more successful than single shot APR. And we also tried a variety of different temperatures for the LLM. So temperature basically determines how deterministic the output of the LLM is. So 0 being fully deterministic, and higher values will try like sampling some randomness into its output. And we found out that 0 is the best value. We found out that the best number of retries is 2, as that would, and yes, and also we found out that in fact, including the previous attempts in the history, in with the latest attempt being the last one in the prompt, code is the best way to show them. So then the final verdict in these experiments was that iterative automated program repair is better than single attempt automated program repair. I'll now give the oh yeah, sorry. So for future work, we just decided to, we're going to be running our approach on open source projects, and we're also going to find a way to include multiple source files into those projects. I mean, into the prompt, so integrating multiple source files, so you can just repair more than one single file. And finally, also we're going to try to run it on some normal C code open source projects. So yes, now I'll pass it over to yeah. So here you go. Thank you very much.
Thank you very much. Hi everyone, my name is Meropitsanadakis. I'm an interdisciplinary criminologist. I will cover the social aspects, and I will start with explaining why this is relevant at all. Because we do know that software developers and software engineers do not apply state-of-the-art methodologies to verify large software systems. So the basic question is, why is this not happening? Which at the same time leave certain vulnerabilities open for being attacked. And the question is why this is happening. So we chose a qualitative approach and interviewed 26 software developers and software engineers working in different industry contexts. We chose, in order to understand which are the practices and behaviors, experience of those software developers and engineers, we covered a wide range. Our sample was covering different aspects, a variety of different software engineers. So we were focusing, for example, on the experience with software verification tools. 5 engineers and developers were not using any verification tools at all. 6 were partly using them or have been using them in the past, but not currently. And 15 out of the 26 interviewees were using software verification tools. Then we covered a wide range of different industry sectors. We covered startups, SMEs, as well as large companies, some of which Mustafa has already mentioned in the beginning. So overall, we have conducted more than 20, or especially Laura conducted more than 22 hours of interviews, qualitative interviews. We have approximately 450 pages interview transcripts, which we are still analyzing, as you can imagine. We used qualitative content analysis as a method in order to systematically make sense out of the 450 pages, and used findings briefing event as a way to verify our findings, our preliminary findings with our interviewees. I can tell you it was different because everyone was based in a different time zone to find a time slot that is usable for most of them. But we were quite successful with that. With this slide, I want to give you an overview of what we did find. So we know from the literature that the first 3 themes, trustworthiness, scalability, and usability, are challenges to using software verification tools. The 4th theme, which is an organizational one, covering company and managerial decisions, is a theme that emerged out of the interviews which we conducted. In the following, I will just give you an illustration one example for each of the 4 themes, because we don't have enough time to cover every category. So I will start with trustworthiness. Trustworthiness, as a social scientist, it would be trustworthiness between people. When we collaborate with computer sciences or technical sciences, it is about how trustworthy is the outcome of a software verification tool, right? So the maturity is linked to the accuracy of a tool. The more a tool has been used in the past, the more software developers and software engineers do regard the outcome of the tool as trustworthy. These, what you can see here, are quotes, an example that illustrates this category. So I'm not going to read it through, but if you have the time and are interested, please feel free to go ahead. I will move on to the next theme, which is scalability. It is related to how to address the issue of when a software system becomes more complex. And here I'm focusing on challenges with regards to time as well as the code base. The more complex a system is, the more difficult it is to verify it. So, and now I forgot. All right. The outcomes of when verifying large software systems, this is a very time-consuming task, and this poses certain challenges when software developers and engineers have to meet deadlines, have to meet customer satisfaction, and have to work on multiple projects at the same time. I'm moving on to the 3rd theme, which is usability. Usability is about what are the challenges that come with using software verification tools. And the one theme we're focusing on here is the need for further education. Why? Because the current documentation is quite challenging. Not many software developers and engineers do understand the documentation as it is currently, especially not if they don't have an academic background. And I'm going to read this one quote because it nicely illustrates what usability is about. For research tools, it could be improved because you always have a paper attached to the tool, and it's not so user-friendly. It's made from researchers for researchers. It has been presented at a conference, so it's quite technical. Not all of us have a nice, user-friendly documentation. So this is why usability is important, as you can imagine. And the 4th theme we're covering here is about managerial decisions. So software verification tools actually can be quite costly. And if the company does not understand what are the benefits with using and investing in those tools, they won't make the investment in the first place. And this brings me to our recommendations. So what does it need in order to understand, fix challenges and fix large software systems with verification tools? All of these recommendations actually are linked to each other, and I hope it makes sense. The first one is about engaging companies bless you, from a very early stage on, in order to make them more mature, to improve documentation, and to offer better support for the companies. The second one is focusing on we need more knowledge exchange between academia, who develops the software verification tools, and the industry who applies them. Third one, we need to have more training for software developers and engineers in order to enable using them in an easier way. And the fourth one, it is probably the most challenging one, as we know from a practical perspective, is raising awareness at the higher managerial level about the benefits of those tools. And with this, I would say thank you very much, and looking forward to your questions.
Yeah, so we've got a couple of minutes for questions, I think, before we wrap up. Tony? quick question. I realise I've probably got a room full of academics and I'm a PS person, so I'm probably out of my depth here. But one of the thoughts I've got is the OWASP project. I don't know if that means anything, but in terms of where to take the higher level and how to bring people like me to a place where we think about code efficiency, repositories, peer reviews, but also those kind of things where we check, you know, the syntax and the various technical bits of the OWASP top 10. It just occurs, I'm not quite sure who's working in that, I don't mean our organisation, but generally, who's working in that area to make sure that large language models and AI and that kind of world is, you know, bringing in on the top 10, not the top 10 things like SQL injections we always used to have. Is there something else now that someone, maybe somebody in this room should be saying, hey, I've got a new top 10 entrant coming in. Have you thought about DNS, have you thought about, I was going to say DNS poisoning, have you thought about large language model poisoning as a threat, and here's some kind of capability that we could put in there. Second, when I was at the bank, and I'll give way in a second, when I was at the bank before I came here, we used to use something, I don't know if you've ever used a product called Black Duck, but it was a thing that we use, and somebody said the code repositories that we've got were hugely inefficient, and you know, looping round and round and round before it eventually spat something out. And again, I don't know whether that's helpful or not, but it was something from an industry point of view that we were looking at that. We were looking at static and dynamic codes and integration code testing and all that kind of thing. But in this AI sort of large language model world, it feels like someone somewhere is probably updating all of this, but I don't know if that's helpful.
Who wants to take it? So, OWASP, they release the top 10 vulnerabilities every 5 or 6 years.
Yeah, maybe Mustafa, yeah.
Yeah, so I do teach them a bit. I use OWASP this 10 as example. So in my slides we have 2014. They released 2019, so I updated my slides. So it is expected now they will release either end of this year or beginning of next year a new top 10. So maybe something related to generative AI or large language models will pop up there. So the second question, actually these software verification tools, we don't claim that they are a silver bullet which will solve everything,
Sure.
but we want to use them as a complementary to all the other techniques that you mentioned.
Variety, but I'll just ask one to begin with. When you were interviewing engineers or software engineers, were they all in specific domains or specific companies? How did you decide who to interview?
We gave it all to try to recruit people. So I think we just wanted them to be software engineers or software developers, at least to have such backgrounds, because some of them more on managerial roles, like not really the top, but we wanted them to have either to be part of the software development teams or to lead software development teams. And we didn't really, well, we wanted to have variety, big companies, medium companies and small companies, and we just like try to approach everyone that we know and ask them to participate, and using LinkedIn's, posting posts like on LinkedIn, going into specific groups within some societies within LinkedIn.
We really did advertise the invitation to participate in the research very widely, using different online spaces as well as LinkedIn, for example, but also more communities which are revolved around specifically targeting for software developers and engineers, where they exchange with each other.
Okay. Because I think you might get different results depending on what kind of product they're developing.
Mm-hmm.
So if they're developing something for a highly regulated domain like aerospace or something like that, I think you might find completely different answers to the questions than what you presented. You'll get some of the same things, of course, but I think in areas like where it's almost mandated to use verification or role verification, I think that you'll find more people using it.
So
for example, Amazon are using it like crazy, but
so
they might not
we touched, so some of the companies, some of the developers we interviewed, they were part of companies that develop critical infrastructure, software for critical infrastructure, and they do use them. Yeah, we see that they use them, but other companies they don't.
One interesting insight for us was, depending on the size of the company, we got different results. So it made a difference if it was a startup or an established, as Amazon, for example, or Google, or etc. But it's a very good input. Thanks.
Sorry, Robbie. One final question. I know you've been keen to ask a question, and I missed you out last time. So one last question, and then we'll wrap up, I think.
My question is to Yanis.
Oh yeah.
So, it's a bit technical. You mentioned that iterative APR is more accurate. So,
Yeah.
when we tend to use LLMs for finding and solving bugs, it tends to, like, after a certain number of turns, it tends to miss out some points that we mentioned at the start. So,
Yeah.
how do you tackle that in your research?
Well, that's the idea behind having like a history to the prompt, because you have the beginning which has like it has the initial state of the code, and then the initial counter example, and then as you build, you keep the initial information, and that's why we had a maximum of 5 attempts, like during the iterative process. And that's the reason why we found out that the best number of iterations in this scenario is 2, because afterwards I think the generation kind of veered in a direction that wasn't that it shouldn't have. So I mean there's like it's an open like question for like reducing this, like it's something that should be researched.
Perhaps at every iteration you start with a sentence, please take, or end with a sentence, please take into account the whole history, read it again before attempting to answer. Something like that might improve.
Yeah, but it's like all prompt engineering research. You gotta find like the correct way to fit everything into the context, and then how to style the prompt, what information to include, exclude. The main limitation in this case was that because it is AIC code, it's quite large, because you gotta fit in all the weights in a giant like matrix. So that's why we ended up like not being able to fit everything in. We had to cut it and use single line, like show only the single line that is broken, or show a contextual area around the faulty line. But yeah, like the main issue is the context, and also the counter example, because due to the size of the matrix, and like there's a lot of state assignments like in the counter example, so then you need to also be smart about that. And this was very exploratory, so we tried basic things and we found out what worked.
Thank you.
Yeah,
Great.
no problem.
Okay, thank you all three. Just leave.